same formula the one is correct. See, f dash x is equal to limit h
Good
tends to
evening, sir.
0 f x plus h minus fx whole upon h, right? This is the result which is to be used in all the questions wherever it is being asked at the first principle. Now, fx is equal to 2x square plus 1. So what will be fx plus h? Twice of x plus h of whole square plus 1. That is replace x by x plus h. Now, if we use this result over here, limit h tends to 0, twice of x plus h of whole square plus 1 minus 2x square plus 1 whole upon h. Good. Now this will be limit h tends to 0, twice of x plus h of whole square plus 1 minus 2x square minus 1 whole upon h. These two cancelled. Out of these two, what can we take common? Only 2. That is a constant, so it can be written outside the limit part. So twice of limit h tends to 0, x plus h of whole square minus x square whole upon h. How do we complete such limits? Very good. Plus x and minus x. Now it is in the form xn minus an upon x minus a. What's the formula? Nan minus 1. So this 2 as it is, 2 into x to the power 2 minus 1. So this will be equal to 4x. This is the value of f dash x. There's just one more thing to be done in these questions. In this exercise, they are asking the differential at x equal to 1. Am I clear with it? We need to find out the differential when x is equal to 1. So in the last step, in place of x, we will write 1. So final answer is 4. Is it clear? Just a quick recap. Where function was given out to be 2x squared plus 1. So fx plus h twice of x plus h of whole square plus 1. And we need to find out f dash when x is equal to 1. So formula used here, right? And then we have put up these values over here. Plus 1 minus 1 cancel हो गए. 2 कॉमन xn minus an की फॉर्म ऊपर न्यूमरेटर में आ रही है, डिनोमिनेटर में एक x प्लस किया एक x माइनस किया. So now the complete form is xn minus an upon x minus a, which is n an minus 1. So this complete is 4x because we need to find out the differential when x is equal to 1. So in place of x, we have written 1. Right? Do it now. Look for the fifth question. Using the first principle, find the derivative of fx is equal to 10x at x equal to 0. So we need to find out the differential of this function when x is equal to 0. The derivation that we did yesterday, exactly the same thing. That is, first of all, we'll find out 10x plus h. Putting up all these values over here. कल कुछ लोगों को ये वाला question clear नहीं हुआ था, so look carefully for it. 10x plus h minus 10x whole upon h. Now here we'll use the formula for 10x minus 10y. 10x minus 10y is 10x minus y into 1 plus 10x 10y. So this will be limit h tends to 0, 10x plus h minus x, 1 plus 10x plus h into 10x whole upon h. Now this x and this x cancelled. Limit h tending to 0, 10h upon h into limit h tending to 0, 1 plus 10x plus h into 10x. The exact derivation. Now 10h upon h is 1. Here in place of h we will write 0. So 1 plus 10x into 10x, 10 square x. And 1 plus 10 square x will be equal to. So f dash x is coming out to be sec square x. We need to find out f dash x when x is equal to 0. So sec square 0. Sec 0 is 1. So result clear? आपकी वजह से बताएं मैंने पूरा फिर से. That's f dash x is equal to limit h tends to 0, fx plus h minus fx whole over h. Please stop writing and look at the board. Limit h tends to 0. In place of x plus h, fx plus h, this complete expression, x plus h plus 1, x plus h minus 1. Now minus fx, so minus x plus 1 upon x minus 1 whole upon h. So can we write it as into 1 upon h? So this will be limit h tends to 0, x minus 1, x plus h plus 1 minus x plus 1, x plus h minus 1 whole upon h. And then into 1 upon x minus 1 and x plus h minus 1. I've done two things in this particular step. First, I've taken the LCM and then I've flipped that LCM also. That is h I've brought over here in the LCM. Limit h tends to 0. Now simple multiplication. So this will be x square plus xh plus x minus h minus 1. Then this will be minus x square minus xh plus x and minus x minus h plus 1 whole upon h and into limit h tends to 0, 1 upon x minus 1, x plus h minus 1. Now look, this x square and this x square, this xh plus x minus x plus x minus x plus 1 minus 1 cancel. So the only thing that's left is minus h minus h. So minus h would be minus 2h upon h into 1 upon x minus 1 of whole square. Followed. Last three. These two cancelled. Final answer is minus 2 upon x minus 1 of whole square. That's it. So we'll write it in the form of differential. This implies that d by dx of x plus 1 upon x minus 1 is equal to minus 2 upon x minus 1 of x. I hope it's clear. There's nothing different. That is, we just have to use this result. Then we need to put up the values of the two functions and then apply the limit. Be quick. Try doing it without looking at the board. Look. Question number 8. fx is equal to sec square x. Watch out carefully. fx plus h will be sec square x plus h. When we put these values over here, this will become sec square x plus h minus sec square x whole upon h. What is a square minus b square? इससे जो डेरिवेशन मैंने होमवर्क में दी थी वो भी एक बार डिस्कस हो जाएंगी, because exactly the same thing is to be done. So those who were not able to do those derivations, please look carefully. जैसे डेरिवेशन सिर्फ sec x की थी, so sec x में सिर्फ इतना पार्ट आ रहा होगा, sec x plus h minus sec x whole upon h. Now look carefully. Limit h tending to 0. This sec can be written as 1 upon cos x plus h minus 1 upon cos x into 1 upon h and into limit h tending to 0 sec x plus h minus sec x. Sorry, not minus, that's plus. Here if we take the LCM, limit h tends to 0 cos x minus cos x plus h whole upon h into limit h tending to 0 1 upon cos x plus h. मैंने यहाँ फ्लिप कर दिया एलसीएम को और यहाँ पर हम लिमिट पुट अप कर देंगे तो sec x plus sec x. I hope this step is clear. दो चेंजेस किए, एलसीएम लिया और फ्लिप. Now we get a minus sign common here. What's the need? What's the requirement for taking minus sign common? Because cosy को minus cosy तो यहाँ पर भी use हो सकता है. But if you remember in Trigno we have done the term with a greater angle should always be written first. इससे plus minus की mistake नहीं करोगे आप. So we take minus sign common. Limit h tends to 0. Cos x plus h minus cos x whole upon h. Into यहाँ लिमिट पुट अप करेंगे तो cos x into cos x. यहाँ तो ऑलरेडी 2 sec x हो गया. Now cos c minus cos d. So this is limit h tends to 0 with a negative sign outside. Cos c minus cos d. जो अभी आपने डेरिवेशन में किया था. This will be minus 2 sin 2x plus h upon 2 and sin h upon 2 and upon h into यहाँ पर लिमिट पुट अप ऑलरेडी हमने कर दी थी, थोड़ा सा सिंप्लीफाई कर लेते हैं. तो दिस इज 2 sec x upon cos square x. Minus minus will be plus. Limit h tending to 0 sin 2x plus h upon 2 into limit h tending to 0 sin h upon 2 upon h into 2 sec x upon cos square x upon 2 upon 2. This 2 and this 2 cancel. Now यहाँ पर अब जब हम लिमिट पुट अप करेंगे तो this will be sin x. This will be 1 into 2 sec x whole upon cos square x. Now sin upon cos 1 upon cos sec. एक sec already है यहाँ पर, so this will become 6. So this is the value of efficiency. थोड़ा सा लेंदी जरूर है but difficult है. So just a quick recap. यहाँ पर एक्सप्रेशन था sec square x, so fx plus h will be sec square x plus h. f dash x में सारी वैल्यूज पुट अप की. यहाँ पहले a स्क्वायर माइनस b स्क्वायर का फॉर्मूला यूज कर लिया. प्लस वाले में क्योंकि फॉर्म 0.0 नहीं होती, यहाँ पर हमने लिमिट अप्लाई कर दी. इसको cos की फॉर्म में कन्वर्ट किया, एलसीएम लिया, फ्लिप किया. यहाँ cos c माइनस cos d फॉर्मूला यूज किया, लिमिट को डिस्ट्रीब्यूट कर दिया. तो sin x into 2 sec x upon cos square x, sin upon cos tan this 2 as it is. And then sec x already था, अपॉन में cos था तो वो sec हो गया, that is 6. Right? Note it down.